Now what we want to be able to do is create polynomials that are good approximations for certain functions, because polynomials are easy to work with rather than the function themselves sometimes. Okay, so we're going to go through the process first and then we'll go back to this general idea up here. So let's say the function is natural log of x, and I want to come up with a first degree polynomial, so a line that's basically a tangent line to natural log of x at x equals 1. I want to also come up with a quadratic or the second degree polynomial that would be a good representation for natural log of x, third degree, fourth degree, etc. Okay. So first thing is you need to calculate whatever order polynomial that derivative. So if I want to come up with a fourth degree polynomial, you will need to calculate up to the fourth derivative. So first thing I'm going to do is, since I'm going to create up to the fourth degree, I'm going to calculate up to the fourth derivative. So we're starting with the function natural log of x. My first derivative is 1 over x. This is really x to the negative 1. So my second derivative is negative 1x to the negative 2, which is really negative 1x over x squared. And then same idea, just keep using that power rule. The next one will be 2 over x to the third. The next one will be negative 6 over x to the fourth. So there are all my derivatives. Next thing we're going to do is I want to know what happens at x equals 1, or where I'm centered at. So in this case it's going to be 1. So I'm going to plug in 1 for all of these derivative values. First of all, at the function, the natural log of 1 is 0. This is going to give me 1, this is going to be negative 1, this is going to be 2, this is going to give me 6. Okay? So the way that you create your polynomial is, this is the pattern. It is f of c, so in this case it's 1 is my center, so it would be f of 0 plus the first derivative at 1 in this case times x minus 1 plus the second derivative of 1 over 2 factorial times x minus 1 squared, etc., until however many terms we want to get to. So my first degree is going to be 0, because that's f of 1, plus the first derivative, which is 1, times x minus 1. My second degree is 0, again, plus 1 times x minus 1. So these two terms stay, but then I need the second derivative, which is negative 1 times x minus 1 squared over 2 factorial. Third degree, 0 plus 1, x minus 1, plus negative 1 x minus 1 squared over 2 factorial. And I need a third term, which is going to use the third derivative, which is 2 x minus 1 cubed over 3 factorial. And so this pattern continues, and I'm not going to write the 0 anymore, but the next one will be x minus 1 minus x minus 1 squared over 2 factorial plus 2x minus 1 cubed over 3 factorial. Now to get to the next term, I need the fourth derivative, which is 6, so minus 6 x minus 1 to the fourth over 4 factorial. Now let's try one more example where we're going to create the polynomials again, just to get the pattern. Okay, so this is called, going back to here, this is called a Taylor polynomial centered at 1. Okay. Now another type of polynomial is called a Maclaurin polynomial, which is just a special case of the Taylor. Maclaurin polynomial just means that your c value is 0. So the next example, we're going to create a Maclaurin polynomial, which just means a Taylor polynomial. It just happens that the center is 0 for this particular function right here. So again, I want to come up with up to the 6th degree polynomial. So typically we would come up with the 6 derivatives, but I'm just going to come up with the first 3 because there's going to be a pattern to this one. So the function, we're going to start with this cosine of x, and I'm going to calculate the first 3 derivatives. So the next one is negative sine of x, then negative cosine of x, and then I get back to sine of x. And if you notice, the reason why I stop is because the fourth derivative would get me back to cosine, which is this one, and then the pattern would just repeat itself. So at x equals 0, which is what my center is, if I plug in 0, this is going to give me 1, 0, negative 1, 0. Okay? And I just mentioned, okay, after this one, it's just going to repeat itself, so the pattern would just look like this: 1, 0, negative 1, 0. The next one would get you to 1, 0, etc. And you can repeat the pattern over and over again. Okay. The 0-degree polynomial would just be the function itself. F of 0 is equal to 1. Okay. I'm going to skip the first degree and just go to the second degree. The second degree, you're going to start with 1. Then you're going to use the first derivative, so that would be 0 times x. So that's why I don't have the first degree polynomial. The first degree would really be the same as just that, because your derivative is 0. But I do need the second derivative, which is negative 1 times x squared over 2 factorial. And I'm going to rewrite this as 1 minus x squared over 2 factorial. Okay, the fourth degree, it's 1 plus 0x minus x squared over 2 factorial. You need your third derivative term, but notice the third derivative is 0 again, so that's why it's 0x cubed over 3 factorial. And then we just talked about the pattern continues, so the fourth derivative is 1, x to the fourth over 4 factorial. If I simplify this, notice I get to here. Okay, so hopefully you can kind of figure out what do you think the next term is going to be. Even without actually calculating the derivatives, the next term is going to look like this. So this would be your 6th-degree Taylor polynomial, centered at 0, which is really a Maclaurin.